Hi, I'm going to show you how to solve an exponential equation by graphing. So first, let's read the problem. It says Drew's parents invested $1,500 in an account such that the value of the investment doubles every 7 years. The value of the investment V is determined by this equation here, where T represents the number of years since the money was deposited. How many years to the nearest tenth of a year will it take the value of the investment to reach $1 million? So before I do anything else, I'm going to say nearest tenth of a year. I need to round it at the end. Okay. So essentially what it wants to know is it wants to know when this value will equal $1 million. So I'm going to set up an equation. I want to know when my equation for growth is going to be equal to $1 million. To solve this by graphing, I'm first going to go to the y equals screen in my calculator, and I'm going to plug it in. So I'll put the thing on this half of the equation, the 1 million, into my y1. I could put it into my y2. I'm going to do y1 just because. So that's 1 million. I'm counting zeros to make sure I did that right. And then I'm going to plug in the other half of the equation into my y2. In my exponent, so I hit the caret key to get to the exponent, I'm going to do a fraction t over 7. I could use division, but just to show you another trick, I'll do a fraction. I'm going to hit the alpha key, and then I'm going to hit the y equals key, and then option 1, numerator slash denominator, gives me a fraction. Because the y equals screen needs me to use x as my variable, I'm going to put an x instead of t over 7. So I'm just going to keep track x is now my t, my variable. When I hit graph, I'm not going to see anything, and I know I'm not going to see anything because, well, I'll draw it out for you over here. I've basically set up this exponential growth equation such that I have my exponential curve. It's going to be increasing exponentially, and then I have this other line. I want to know when this exponential curve equals 1 million. So I've graphed the line y equals 1 million. And that line is really high up. The right number of zeros, good. That line is up here. It has a y-intercept of 1 million. So of course I can't see anything. By default, my calculator only goes up to 10. So I've got to go to my window settings and adjust some things. So when I go into window, I'm going to change my x-min first. I'm going to start it out at 0. X is my time, right? It represents my time variable. So I'm going to start at 0 years. I don't know how long it's going to take to get to $1 million. It's doubling. It's going to happen eventually. I'm going to go ahead and just set it equal to 100. I'm going to give myself 100 years and see what happens. I can always adjust if I need to. And I'm making my x scale 10 just so we're counting by tens and things look nice. I'm going to set my y million or my y minimum equal to 0. And my y maximum is going to be equal to, well, it's got to go at least up to 1 million. I'm going to say 1,100,000 just so I have a little room to see above it. Okay, counting zeros again looks great. Now, when I hit graph, I should be able to see the first line go. So there's y equals 1 million, and here comes my exponential growth. It's climbing, and they have intersected somewhere about halfway through my time period I gave there. So there is my point of intersection. To figure out exactly where that is, I'm going to go to second. I'm going to go to the trace key where it says calculate, and I'm going to hit the intersect option. I'm going to hit enter for the first curve, enter for the second curve, enter for guess, and there is my intersection. So I can see that x, or in this case it's actually the t variable, I've just substituted x in my calculator, is going to be equal to 65 point, and it's 66, I need to round to the nearest tenth, so 65.7 years. And there is our answer.